Welcome back for another deep dive. This time, we're going to be tackling Yelp's migration from PostgreSQL to MySQL
Oh,
for their
yeah.
Yelp Reservations database.
Wow.
And you might be thinking,
Databases.
yeah, databases. It's going to be
That's going to be kind of a
yeah,
snoozer. But
yeah.
trust me, this is a really fascinating story.
Oh, for sure.
And we're talking about a system here that restaurants are using every day to manage reservations.
Yeah, absolutely critical.
Absolutely critical.
Got to prevent those double bookings.
Oh, man. Can you imagine showing up to a restaurant and having, two parties at the same table?
Oh, the worst.
I mean, that's just bad news for everybody.
Yeah, it is. And this wasn't a simple migration.
Yeah.
Yelp Reservations was really tied in with some of the specific things that PostgreSQL can do.
Uh-huh.
Things that MySQL doesn't have right out of the
Oh,
box.
so this isn't just a simple unplug this, plug this in,
No.
and everything works perfectly.
No, it was a bit more involved.
Yeah.
I'm curious then, what drove them to even make this move in the first place?
So PostgreSQL was working fine,
Right.
but they really wanted to kind of standardize all of their infrastructure
Okay.
and use MySQL everywhere because MySQL is what their engineers knew really well.
So this is kind of like a using the tools, situation.
Exactly,
Oh,
and what their internal teams knew how to support.
Sure.
So it made it a lot easier to maintain.
Right.
And if something went wrong,
To react.
they could react a lot quicker.
Yeah, that makes a lot of sense because if you have expertise in one area,
Yeah.
then you're not scrambling to find somebody who knows the other system.
Exactly.
So it sounds like it was a very strategic move.
Definitely, and it made things a lot easier for them moving forward.
Right.
To grow and innovate.
Yeah. Well, that's always the challenge, right? Is you want to make sure that your systems can grow with you
Yeah.
as you're developing as a company. But I imagine this migration probably came with a whole host of challenges.
Oh yeah, it did.
So what were some of the biggest hurdles they had to overcome?
So one of the first things is they were using these things called array columns in PostgreSQL,
Okay.
and MySQL doesn't have anything like that.
And what were they using those for?
So those were used for storing restaurant table schedules.
So like when a table's available, when it's not.
Exactly.
Okay.
So that's not something that MySQL can do.
So how did they get around that? Did they have to completely redesign the way that they were storing their data?
So this is where it gets kind of clever.
Okay.
Instead of doing this huge redesign,
All right.
they realized they could just pack all of that data into strings.
It's just strings.
Yeah.
How does that work?
So the length of the array and all the data in it was always the same.
Okay.
So they could just cram it all together.
Oh, so they could just kind of concatenate it all into one big string.
Oh,
And MySQL could handle that.
yeah, and that worked out great.
Oh, okay. So that's pretty clever. It sounds like they really had to think outside the box to figure that one out.
Oh, for sure.
But I'm sure there were other things that PostgreSQL does that MySQL didn't have a direct equivalent for.
Right.
What about database triggers?
Yeah.
I understand those are really important for preventing double bookings.
The triggers were huge.
Yeah.
So MySQL does have triggers.
Okay.
But Yelp couldn't use them the way that their system was set up.
Oh, okay. So they were kind of stuck with what they already had,
Oh.
and they couldn't just plug in the new MySQL trigger system.
Right. So they had to come up with a different solution.
So what do they do?
So instead of using triggers, they added some logic in their Django application.
So they moved the logic from the database up into the application itself.
Exactly.
Okay.
And this code would publish these things called AMQP events.
AMQP events.
Yeah.
What are those?
So it's basically a way for different parts of the system to talk to each other so that they could always stay up to date.
So anytime something changed, they would all get a little message saying, hey, this is what just happened.
Exactly.
Okay. And that helped them prevent those double bookings.
Right, because everybody knew what was going on.
Gotcha. So it was like a real-time update system.
Yes, exactly.
But did that have any drawbacks?
So it was a trade-off.
Okay.
It gave them more control over how they handled the updates.
Right.
But it did cause some performance issues that they had to deal with.
Because instead of doing things in bulk, they were now doing things one at a time.
Yeah.
Okay, so they had to make some adjustments to account for that.
Right.
Gotcha. So that takes care of the triggers. How did they deal with the actual problem of double bookings without those triggers?
So they had this system called atomic block holds before
Okay.
that prevented overlapping reservations.
Right.
And that relied heavily on those triggers.
Gotcha.
So to replace that, They created a whole new table called table time slot block.
Table time slot block. That's a mouthful.
Yeah.
What did that do?
So basically, it tracks the availability of each table
Okay.
in 15-minute chunks.
So they broke it down by 15-minute intervals and said, okay, is this table available during this 15 minutes? Is it available during that 15 minutes?
Right.
Okay.
And it was constantly checking for conflicts.
So instead of waiting for a conflict to happen, they were like, okay, let's just see if there's going to be a conflict before we even let somebody book.
Exactly.
Okay.
And it worked really well.
And it was as effective as the trigger system.
Yeah. They did a lot of testing
Okay.
to make sure that it worked just as well.
And I'm guessing they were looking at the logs to make sure that the old triggers weren't firing anymore.
Oh, yeah.
Because if they were, that would be a sign that something wasn't working, right?
Exactly.
Wow, so this is really impressive stuff.
Yeah.
But, let's be honest, no migration is perfectly smooth.
Right.
It always surprises.
Oh, yeah. Definitely.
So what were some of the unexpected things that popped up along the way?
So one thing that they ran into was these auto-incrementing primary keys.
Okay.
It seems like a small thing,
Sure.
but it actually caused a lot of problems.
Oh, really?
Yeah, because PostgreSQL and MySQL handle them a little bit differently.
In what way?
So they were writing to both databases at the same time.
All right, it's part of the transition.
Exactly.
Okay.
And that caused PostgreSQL's key sequence to get messed up.
So it was like getting ahead of itself.
Yeah, and it caused some transactions to fail.
Oh, wow. So this tiny little difference between the two systems caused a major headache.
Yeah, it did.
That's incredible.
It just goes to show you that you really have to understand the details
Oh, yeah.
of both systems.
The devil's in the details, as they say.
Exactly.
This has been a fascinating look into the challenges that they faced.
Yeah.
But before we jump into the actual release,
Okay.
I'm curious about one more thing.
Sure. So they did this initial data load.
Right. To get MySQL up and running.
Yeah.
Okay.
And they learned that you really need to do a second backfill.
After you fixed all the bugs.
Exactly.
So even though they had fixed the code, some of that old data that had been loaded with the buggy code
Was still causing
is
problems.
still causing problems.
Yeah.
So it's like you patch a leaky pipe, but the floor's still wet.
That's a great analogy.
You got to clean that up.
Yeah.
Okay, so they've tackled all these technical challenges.
Right.
They've learned some valuable lessons along the way.
Yeah.
Now comes the moment of truth,
The release.
the release.
Yeah.
This wasn't a system they could just take offline for a few minutes and swap everything out. Was it?
No.
This was live 24/7.
Mission critical.
Mission critical.
Yeah.
So how did they manage to actually pull this off?
So they had this really smart phased release strategy.
Okay, so tell me about that.
So instead of just switching everything over at once,
Right.
they did it very gradually.
Okay, I'm all ears. How did this work?
So they kept both databases running at the same time
Okay.
for a while.
PostgreSQL and MySQL both humming along
Yeah.
in parallel.
And they were writing data to both systems.
So they're writing to both databases at the same time.
Yeah.
Wow, that's a lot of data.
It is, but it gives you a really good safety net.
Right. Because if something goes wrong on the MySQL side,
You can always switch back.
you can just flip the switch back to PostgreSQL
Exactly.
and nobody even knows.
Yeah.
Okay, so that's smart.
Mm.
So they're writing to both, but what about reads? How did they handle the reads during this phase?
So at first, most of the reads were still going to PostgreSQL.
Okay.
That way, everything would keep working the way it always had.
So they could make sure that nothing was broken
Right, and it gave them time to fix any bugs.
without affecting the users.
Exactly.
So it was like a dress rehearsal
Yeah.
with a live audience, but the audience doesn't know it's a rehearsal.
Yeah, that's a good way to put it.
So what was the next step in this intricate dance?
So once they were confident that MySQL was working properly,
Yeah.
they started shifting the read traffic over.
Gradually.
Yeah, very slowly.
Okay.
And they were monitoring everything very closely.
So they're like turning up the volume on MySQL
Yeah.
and turning down the volume on PostgreSQL.
Exactly.
Okay, what a balancing act.
It was.
So once they had most of the reads going to MySQL,
Yeah.
what did they do?
So then they switched things up. So they were writing to MySQL first
Uh-huh.
and then to PostgreSQL.
So they flipped it.
Yeah.
Okay, so now MySQL is the primary
Right.
and PostgreSQL is just kind of the backup.
Exactly.
And how long did they run in that configuration?
So they did that for a few months
Okay.
just to make sure everything was stable.
Make sure there were no hiccups, no surprises.
Right.
And then finally,
They turned off writes to PostgreSQL completely.
the moment of truth.
Yeah.
I'm guessing it all worked out.
It did.
Okay, good.
The migration was a success. They were able to get rid of the PostgreSQL database,
Yeah.
and everything was running on MySQL.
Okay, so all that careful planning paid off.
It did.
But let's talk about the outcome. Was it actually worth all this effort?
Oh, yeah, definitely.
So what were the benefits that they saw?
So they were able to maintain things a lot easier.
Okay,
They had a lot more visibility into what was going on.
gotcha.
And if something went wrong, they could respond a lot quicker.
So operationally, it was a big win for them.
Yeah, absolutely.
Okay, what about performance? Did they see any performance improvements?
So the performance improvements weren't really because MySQL is faster than PostgreSQL.
Okay,
It was because they were using Yelp's standard infrastructure now.
right. So all the optimizations they had built for MySQL in other parts of the system
Yeah,
now applied to Yelp Reservations.
exactly.
Okay, so it was kind of like a side benefit.
Yeah.
So they got improved operational efficiency and a performance boost.
Right.
That's pretty impressive.
It is.
But, they did run into some unexpected challenges along the way.
Right.
What were some of the key lessons they learned?
So one of the big things was to really think about the operational side of things,
Wow.
not just the technical side.
So, how easy is it to maintain?
Yeah,
How easy is it to troubleshoot?
exactly.
How easy is it to support in the long run?
Right. Because all of that stuff matters.
Yeah, and sometimes the best technology on paper
Yeah.
isn't actually the best fit
Right.
for your organization.
It depends on your situation.
What about the data migration itself?
Okay.
Did they have any specific advice about handling all that data?
So they really emphasized data integrity.
Okay.
Making sure that nothing got lost or corrupted.
Yeah.
They use a lot of checksumming.
Checksum. So basically calculating a fingerprint of the data
Yeah.
and making sure that it matches on both sides.
Right.
Okay.
Yeah.
And that helps you catch any errors.
Exactly.
Gotcha. What else?
So they also learned that it's really important to design the migration process so that it can be restarted.
Restartable.
Yeah.
Why is that important?
So if something goes wrong,
Right.
you don't have to start over from scratch.
Like a network outage or a power outage or
Or a bug in your
a
code.
bug in the code. Yeah.
Anything could happen.
So how do you make a data migration restartable?
So one way is to break the data up into chunks
Okay.
and transfer them one at a time.
So if something goes wrong, you just pick up where you left off?
Exactly.
Okay.
Oy.
That's a good strategy. Did they mention anything about a rollback plan?
Oh, yeah. They said that's essential.
So if everything goes completely sideways,
You can always go back.
you can always go back to the original system.
Yeah, right?
Okay. So they really thought of everything.
They did a good job.
Were there any other unexpected challenges that we haven't talked about yet?
Yeah, so one interesting thing came up with ProxySQL.
ProxySQL.
Yeah.
What's that?
So they were using that between the clients and the databases.
And it caused some problems because of the way Django was naming save points.
Save points.
Yeah. Remember those random strings they were using?
Oh, yeah. Vaguely remind me.
So ProxySQL was storing these things called query digests.
Query digest.
Yeah, which are basically simplified versions of the queries.
Okay.
And those digests included the save point names.
Oh, okay.
So every query that used a save point had a unique digest.
Because the names were random.
Exactly.
Oh, wow.
And that caused ProxySQL's memory usage to explode.
So it was like, it was trying to remember all of these unique digests.
Yeah.
And it just couldn't keep up.
Right.
So how did they fix that?
So luckily, the fix was pretty simple.
Okay.
They just changed a setting in ProxySQL.
To exclude the save point names.
Exactly.
Okay, so a configuration change saved the day.
Yeah.
It's amazing how these little things
Yeah.
can have such a big impact.
They can.
Did they have any final thoughts on what makes for a successful migration?
So they said that it's not just about technical expertise.
It's also about planning communication
Right.
and being able to adapt.
Because you never know what's going to happen.
Yeah, you got to be prepared for the unexpected.
It sounds like they really thought of everything.
They did.
But even with the best planning, you can't anticipate every challenge.
Right.
Did they encounter any situations where they just couldn't replicate a feature from PostgreSQL in MySQL?
Yeah, there were a few cases where they had to make some adjustments.
Yeah.
Yeah. So one example is their analytics pipeline,
Oh.
which was pulling data directly from the PostgreSQL database.
Oh, wow. So they had like a whole other system
Yeah.
that was relying on the old database.
Yeah, it's
That they have to migrate that too.
they did.
Okay.
And it turned out to be one of the last things they had to do.
To finally get rid of PostgreSQL.
Right.
Wow, it's amazing how these dependencies
Yeah.
can just kind of
They
hide
just sneak up on you.
until the very end. You're like, oh, wait, there's one more thing. Um, so it sounds like even though they had to make some adjustments along the way,
Right.
Yelp ultimately achieved their goals.
They did?
They improved their operational efficiency.
Yeah.
They got a performance boost,
Uh-huh.
and they ended up with a more standardized infrastructure.
A lot of wins.
Yeah, a lot of wins. Um, so their story is really a testament to,
Yeah.
the importance of careful planning,
Absolutely.
creative engineering,
Yeah.
and a phased approach to reduce risk.
It's a great example.
Yeah. What does this all mean for our listeners?
Okay.
What are some of the key takeaways, especially if they're facing similar migrations?
So I think the biggest takeaway is that, these migrations aren't just about the technical stuff. It's
Mhm.
also about how you plan,
Yeah,
how you communicate,
Yeah.
and how you adapt to the unexpected.
because there are always going to be surprises.
Oh, yeah.
Always, no
that-
matter how much you plan.
Always something.
And, we talked about this earlier, but it's really important to choose technologies
Right.
that align with your long-term operational and maintenance needs.
Absolutely.
Sometimes the best technology on paper
Yeah.
isn't actually the best fit
Right. It depends on your situation.
in your organization.
For sure.
Any other words of wisdom?
I would just say, even with the best planning, surprises are inevitable.
Right.
So build some flexibility into your approach.
Uh-huh.
View those challenges as learning opportunities,
Okay.
and always have a rollback plan.
Yeah, because you never know when you might need to go back.
Never know.
Well, this has been an incredible deep dive
Yeah, it has.
into the world of database migrations.
Very complex.
Thank you so much for walking us through this fascinating story.
Oh, it was my pleasure.
And to our listeners, we hope you gained a new appreciation
Yeah.
for the challenges and the triumphs
Yeah.
of migrating these mission-critical systems.
Hopefully you learned something.
And maybe you even pick up some valuable insights
Yeah.
to help you tackle your own technology challenge. Good luck out there.
Before we go, I'd like to leave you with a thought-provoking question.
Okay.
What other hidden challenges
Yeah.
might arise when you're migrating between seemingly similar technologies?
That's a good one.
What complexities might surprise even the most seasoned engineers?
Yeah. Think about that.
It's a reminder that in the ever-evolving world of technology,
Yeah.
there's always more to learn,
Always something new,
always more to discover,
for sure.
and always more to explore.
Keep learning.
So until next time,
Yeah.
keep diving deep
Dive deep.
and never stop being curious.
Stay curious.
We'll see you in our next episode.
See ya.